Hi everyone, today we're going to be looking at Modbus RTU. We'll use the Click PLC as a master to the BRX PLC as a slave for communications. And the first thing we'll do is take a look exactly what we want to do here. So if we look at, this is all from the Click point of view, and what we want to do is we want to read Modbus address 40,001 to 40,010, and what that will do is read from the BRX PLC MHR1 to MHR10. They are mapped right to those locations, and we'll store that information in DH1 to DH10 in the Click PLC. So we're actually reading the 10 registers from the BRX PLC into the Click. Then what we want to do is write information. We're going to write Modbus address 40,011 to 40,020, and we will actually be writing that into the BRX PLC at MHR11 to MHR20, and that corresponds to DH11 to DH20 in the Click. So we actually write the 10 registers to the BRX PLC. So we've set up a block of memory areas, 20 of them. The first 10 are reading, the second 10 are the write from the Click point of view. Our wiring diagram, we can actually see up here that we're actually using a 485 connection, which is a 2-wire, and we don't have the optional logic ground or the LG connected. And here we have our COM port here, so there's my twisted pair here. It goes over to our BRX PLC twisted pair into this serial port here. You'll see that on the BRX we actually have a termination resistance. This is set through the software, which we'll see in a minute here. So that's my connections themselves into from the Click PLC to the BRX PLC. So we'll close that now. And looking at online, we'll look at our slave BRX PLC first. And what we'll do is call up our configuration. And under the configuration, you'll notice that we have our serial port configuration under a protocol. We have the Modbus RTU Server as a set to a slave, which is exactly what we want. Then under port type, we have RS485. We have enabled the 120 ohm termination resistor. Then if we go to our device settings, you will see that we have our baud rate, 38,400. We have our data bits at 8, we have our stop bits 1, and our parity at 0. This is important to make sure that we have both sides the exact same in order for us to communicate. So we'll say OK, and we'll say OK to that. And because we're online with the BRX, as soon as we change that, it automatically will update what's in the controller itself. So on our screen, or on our program itself, on our BRX, all we have is we take the write channels that are coming in, which is going to be MHR11 bit 0 all the way up to all the different bits that we have, and we're going to turn on the actual physical output Y0. So we'll do that all the way down. You'll see MHR11 bit 3 turns on output 3, 4, 4, 5 to 5, 6 to 6, and 7 to 7. So a very simplistic program. We actually use the casting feature of our BRX PLC in order to do that. And right now we are in run mode. So everything's running. So our slave unit is set for our communication. Next we'll call up our BRX, or our Click PLC, and here's our Click PLC now. And again, if we go to setup, we'll go to COM port setup, and over here we look at port number 3, setup, and here you see our protocol is already set for Modbus, our node address 1, our baud rate 38,400, just the same. We have our odd parity, we have 1 stop bit, we have 8 data bits. And you'll notice that with the Modbus communication standard, 8 data bits is the only option you have for this selection. So our parameters for our serial ports match each other, so that's very important to have. So we'll say OK. And now, if we look at the program, we have basically a receive. So we're asking for reading of the 10 registers that we want, and we'll call up that instruction, and it's calling it from slave ID 1. We're going to read holding registers. There's our starting address, and we're going to store that information in the Click PLC starting at DH1, and we're going to read 10 registers. Then we set our status flags here, our receiving, our success, and our error flags. And we'll use the success and error flags in order to trigger the sending and receiving of our instructions. So we said OK. And that's exactly what you see here. We have the receiving, which is our reading, and it's taking the write instructions, which is the next instruction we'll look at, to actually write. We also trigger that read instruction from our first scan in order to start the communications happening. If we cursor down, we will actually see our send instruction, and here is our send instruction. We have our slave ID serial device, which is 0, which is our actually broadcast. So we're sending this out to everything that's on the network, which in our case we only have the one controller, but if we had several, we could send that all out in one instruction set. And we're going to write multiple registers. Our addressing, 40,011 is where it's going to start. We're going to start the master address at DH11, so it grabs the information at DH11 and writes it out to COM port, and we're going to do 10 registers. Then we set our status flits, our sending, our success and errors, and again our success and error flags are used for doing the communication between the send and receive instructions. So we'll say OK. And then the last part of our program that we have here is just a copy. And our copy, what it will do is take DH1, which is the first register of our BRX PLC that we're reading in, and it's going to set individual bits on the output side so that we can actually see them fire on the PLC. And then we just have our end statement as our last thing of our program. Right, so we'll go back here. The last thing we'll do is put this into run mode now. So we'll go here, we'll hit run. Okay. So now we're running, and if you look at the extra communication port, we have our transmit receive lights on in almost the same time, and then what you'll see is our wiring over to our BRX, and our BRX transmit and receive lights are on as well. They're on solid. They're actually blinking every time it's sending and receiving, so you notice that we're really communicating quite quickly. And that is because when we look at the program, we're actually using that send and receive in order to fire the next one. So there's no time delays within our communication. And if we were to turn on the status monitor, what it will do is actually shows us the flashing lights back and forth. Okay. So just to prove that we have communication, what we'll do is we will first of all call up our data view, and on our data view it looks something like this. So this is our click. So what we're doing is we're writing some information here, and the information that we're going to put in here, we'll just put 1, and then we'll write the value. And when we do, we put the 1 in there, but you also see that we turn on our first output as per our program. If we want to change the first 4 on, we'll put an F in there, and the first 4 lights, as you can see, come on. Or we can turn them all on, and we'll write that information, and once again all those lights come on. So the first 8 outputs of our BRX will come on. Now similarly, if we look at our Do-More, and we can actually look at our data view, and on our data view we have a series of information here. Now remember, we set the program up so that when we go to edit, we can edit this value in our first one and turn on our bits of our click. So let's try that 1 again. We'll write that information, and sure enough, the first output actually turned on. If we then will put in value of 3, that would be the first 2. Sure enough, exactly what we expected. And we could actually fill that up or turn all the bits on. Let's put F's in there, and it turns all of our outputs on. Okay, so communication through Modbus is very straightforward. Making sure that you have your wiring correctly and your parameters for each correctly. Now, all the links and downloads can be found on our website at accautomation.ca. If you like this video and like to see more, there are 3 ways in which you can help us out. You can give us a thumbs up so other people can find this information, just as you have. You can subscribe to our YouTube channel at the end of the video. You can also go to accautomation.ca and subscribe to our website. When you do, you get notification every time we publish new content to the site. You'll also get 2 free ebooks on numbering systems and robust data logging. And the third thing to do to help us out is tell a friend or colleague about the site. Alright, that's it for now. Thanks for watching.